Today we're going to learn how to evaluate expressions. We're going to do that by substituting values in for our variables and then using the order of operations. We may have an expression that's long enough to need the commutative, associative, or distributive properties. One thing that we do know is that variables are letters that are used to represent numbers. You can replace the variable with the number they tell you and to evaluate the expression. And they can be almost any letter, but the most common you'll see are X and Y. The vocabulary that we'll focus on is expressions. They're math phrases is how I like to think of them, something like 3x plus 9, meaning 3 times a number plus 9. And equations simply have an equal sign. I think of them as a math sentence. So like 3x plus 9 equals 12. The difference being that one is a phrase and one is a sentence. By the end of this lesson, you should be able to evaluate expressions that include variables. So we'll look at 3 examples today that will help you do your work. So what is the value of the expression when x equals 2? So notice this has no equal sign, but it tells you x equals 2. The first thing to remember is that when you have a number in front of a variable, it means multiply. So this just means 3 times x minus 5. And you will replace your x with the 2. So there's a couple ways we can show this. I'll show both. You can do 3 parentheses 2 minus 5. That's the most common way. And you'll end up with that being 6 minus 5 or 1. But you could also say that this is 3 times 2 minus 5. Again, 6 minus 5 equals 1. Either way, it's the same. What you can't say is 3 times 5 minus 5, only because we might confuse that with an x at this point. So generally speaking, try to avoid the x. It's not really wrong. You can tell that's multiplication, but it's not the best practice. What is the value of the expression below? Now this time we have an x and a y. So we've got our x equals 8 and y equals 7. Pay careful attention here because you have 10 times x. So I'll do my variables I'll replace them in a color. So I'm going to do my 10 and then times x. I'm going to use the parentheses method. So I'll replace my x with what they told me, which is 8. So 10 times 8 minus 4, and I'll replace it with what they told me, and I'll go ahead and switch to red. Y is 7, so 4 times 7. Now I'll just use black from here. 10 times 8 will be 80, minus 4 times 7 is 28. And in your head or showing your work, it doesn't matter, or using your calculator if you need it, you can have your 52. So the value of this expression is 52. The next, what is the value of the expression below when y equals 2? So now we're back to just one variable, but we do have a squared variable or squared value. So I'm going to just write PEMDAS up here. I see no parentheses, but I do see exponents. So I'm going to replace it. I'll do the same thing I did in the last example where I say 9, and then I'll do y squared. So y squared would be 2 squared. And then I'll go back to plus 6. Y is still 2, and then minus 5. So my parentheses I don't have. I did write parentheses for my multiplication, but that's just a way to show multiplication. My exponents is where I am now. So I do 2 squared. So 2 to the second power is 2 times 2. So this turns into 9 times 4 plus 6 times 2 minus 5. My PEMDAS tells me that I have to go and do my multiplication and my division from left to right. I only see multiplication, so I'm just going to kind of check that off and say I can do those at the same time. It's both multiplication, so 36 plus 12 minus 5. And my PEMDAS tells me I do my adding and subtracting from left to right. So whatever I see first. So add 36 plus 12, so 48 minus 5. And now my subtracting is left, so I end up with 43. Okay, again, that's an expression because there's no equal sign. And the last one is an equal sign. It's a very small equation, a short equation. It says, does negative 816 make this equation true? So what they're really saying is, does y equal negative 2x when I replace my x with negative 8 and my y with 16? Well, let's see. So 16 would be put in for y equals negative 2, and x is negative 8. So 16 has already been done. I know it's just 16. And negative times a negative, good time to remember that that is a positive. So I end up with 16 equaling 16. So yes, it makes its equation true. You might be recognizing this as a check when you solve something. Your assignment today is going into Delta Math. You'll have a link in your class, and please open your composition book to a new page and label the top with evaluating expressions. Make sure you show your work in your composition book.